teach, to do, because that's where all the games happen. Learn about things like chance and, what are the odds of this and what's the probability of that. I just have a lot of fun with this particular unit. Now, a lot of this, what we're doing today, is probably going to be pretty familiar to you because the first lesson is just basically introducing probability. Most of us have had some sort of introduction to probability in middle school, maybe even earlier than that. So looking at 5th, 6th, 7th, 8th grade, you've probably seen a lot of this basic stuff. But let's review the basics so that as we get into things that are a little bit more complicated, it'll be easier if you remember, oh yeah, that's how we set up the probability. So the goal of the unit, of course, is to find the probability of an event occurring. And for today, we're also going to talk about finding the odds in favor of something and the odds against an event happening. A lot of times people interchange the word probability and odds. They mean similar things, but they actually are not synonyms. You can't use one when you mean the other. The probability of an event is different from the odds in favor of that event happening. And a lot of it has to do with the formula. So we'll take a look at that in more detail. Now this unit is very vocabulary intensive. Unfortunately, you can't see all of the vocabulary. Scroll it up a little bit. There we go. So as we go through this, these are the vocabulary terms you need to be familiar with. Sample space, probability, outcomes, favorable outcomes, theoretical probability, experimental probability, simulations, we're really not going to get too much into, and odds. Odds in favor of an event happening, odds against an event happening. Alright, first we're going to look at what is probability. Alright, so the probability of an event, probability, P, alright, it's usually represented, actually, not usually, it's always represented with P, of an event is a measure of the likelihood of it happening. Alright, what is the chance of this thing actually happening? Now, it is a number between 0 and 1. So let's say we're talking about number cubes. If I'm going to roll a number cube, okay? And I'm going to know what's the probability of rolling a 3. When we write about probability, generally speaking, we can shorthand it. We can simplify the equation to be P, and then in parentheses, whatever the event is. And then equals whatever the value is. Now again, probability is on the number line between 0 and 1. Right? 0 means impossible. Right? Not going to happen. There is no chance, not even 1 in a million, or 1 in a trillion, or 1 in infinity, of this event occurring. Whereas 1 means it is a certainty. Right? It will happen. There is no way for it not to happen. And then in the middle of all this are all the infinite combinations of things happening. Of course, right smack in the middle, we have the probability of 1/2, or we could write that as 0.5, or, of course, 50%. So the probability of something happening is 50%, or 1/2, or 0.5, whatever your version of writing it down is. That means it's as likely to happen as not. As likely as not. Oops. Yeah. Is the right word? Not. I call it Alan. As likely as not to happen. Meaning 50-50. It could happen. It could also not happen. Now, to be able to figure out the probability of something, we have to first look at the outcomes. So let's look ahead. Well, actually, before I switch to the next slide, let's talk about other things with the probability. If I have a probability that is greater than 50%, so anything that's greater than 1/2 or 50% or 0.5, that means it's likely to happen. Alright? And of course, the closer to 1 that it gets, the more likely to happen it is. Like there's a 90% chance of rain tomorrow. Alright? Pretty darn likely that it's going to happen. Now, it's not a certainty. You may think it's a certainty, right? 90% chance it's going to rain, all right? But it's not. It could not rain. That's why weathermen always have this probability to have an out if they estimate the weather, but it's pretty likely that it's going to happen. Whereas anything that's less than 50% is unlikely. All right? And the closer we get to 0, the more unlikely it is that the event will happen, like winning the lottery. 1 out of a million chances, or however many chances, that's pretty unlikely to happen. It could happen, there's that one chance, but it's pretty unlikely that it's going to happen. So probability is basically on this stream from 0 to 1. All right, let's take a look at how we find probability. All right, the probability of an event when all of the outcomes are equally likely. Equally likely, that is very, very important here. The probability that an event will occur is given by the formula. Probability of the event is equal to the number of favorable outcomes over the total number of possible outcomes in the sample space. Now, generally speaking, when you're trying to find the probability of an event happening, you want to know what are all the possible events. So let's go back to the example I said just a moment ago. If I have a number cubed, what's the probability of rolling a 3? Well, we have to think to ourselves, well, what are all the possible events that can happen? What are the possible outcomes? I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Now, the fact that I listed these, that's the sample space. All of these possible outcomes are the sample space. Now, the total number of outcomes in the sample space, well, there's 6 possible outcomes, 6 different numbers that I could roll. I want to know what's the probability of rolling a 3. Well, there's only one 3, so that means there is one outcome that is favorable to the event. Okay? So then, write that as a fraction. Fraction is probably the most common way of writing probability since we have it in fraction form. But you can also write this as a decimal or as a percent. So as a decimal, of course, this keeps going and going and going. We generally round that to 0.167. Again, 3 decimal places, pretty nice and easy. And we can put that as a percent. So 16.6% or 16.7%. All right? So fractions, decimals, percents, these are the most common ways of writing our probability. Let's take a look at some examples, other than just this easy one, okay? So, our first example is finding the probability of an event. Now I'm going to have to write this down, and I want to use the example that was given to me. Unfortunately, not the best when it comes to making charts and tables in the book, and I don't like having to necessarily cut and paste all the time, so we'll take a second. We'll draw this example out for us. All right. Now again, work with me. This is not, oops. Oh, no, I don't want to do that. And there we go. I'm going to draw over it. Perfect. Much better. Okay. And I'm going to have, these are supposed to be as even as possible. I'm drawing it, so obviously it's not the best, but we'll work with it. Alright, so there are our options. So this is a spinner. You're not going to game, so we spin it. We'll draw an imaginary arrow. Now, when you see pictures of spinners, you'll always have that arrow landing on an outcome, but that's just to show you that it is a spinner. So don't be so focused on what the picture is showing you about the arrow. Just look at the question and look at the possible outcomes. Unless the question asks you, what is the outcome shown? All right, so suppose you spin the spinner at right, which is divided into equal parts. Find the probability of the event. First question says, what is the probability that the pointer lands on 2? All right, well, we're looking at the spinner, and I have 1, 2, so that's one favorable outcome out of 8 total outcomes. So my probability, simplest fractions, 1/8. Of course, I could also write this into a decimal or a percent. care which you use, if you use a fraction, a decimal, or percent, as long as, of course, it's correct. If you use a fraction, it needs to be in simplest terms. So simplify your fractions, reduce it to its simplest terms. All right, the pointer lands on an even number. So we're looking at our choices. 2 is an even number, 8's an even number, 10's an even number, 12's an even number, and 16 is an even number. So that means there are 5 favorable outcomes. There are 5 even numbers out of the total of 8 possible choices. So then, again, putting this into our fraction or decimal, we could have 5/8 or 62.5%. Now notice that this is slightly greater than 50%, so this is more likely to happen than not to happen. So if you were going to guess if it was going to land on an even number, and you said yes, right? You're more likely for it to land on the even number than for it not to land on the even number. So you're not a bad choice. All right. Now, again, another thing before I erase this, I tend to draw on the pictures provided, such as circling my favorable outcomes and things like that. That's helping me very quickly identify those that I want to happen and ignore the ones I don't want to happen. All right, let's move on to our next example. Types of probability. So we have theoretical probability and we have experimental probability. Theoretical probability, it's theory, right, talking about the mind, the all-knowing, all right, it's based upon you knowing all of the possible equally likely outcomes. So if you're rolling a dice, you know what numbers are on the dice. If you're flipping a coin, you know what sides of the coin, heads and tails. If you're drawing a card, you know what's in a standard deck of cards, you know, ace through king, and then there's 4 different suits. You know all of that beforehand, so you know what the possible outcomes are. Just like in our previous example, we could see the spinner, we could see all those outcomes. Now, experimental probability is experiments. Now, this is not just scientific experiments. We're not talking about being in a lab coat stuck in a laboratory somewhere and doing experiments on gene therapy or botany, which is dealing with plants. All right? But it can also be based upon surveys, going out and gathering information from people, historical data, doing research, or simple activities like flipping a coin, rolling a dice, pulling a card, right? These are all examples of experimental probability. Sometimes we know all the possible outcomes, and sometimes, like scientific experiments, we don't necessarily know what's going to happen. We just do enough trials to figure it out, and hopefully we counter all of them, but sometimes we just don't know. All right, let's look at our example. To help choose a mascot for a new school, 200 students were asked to pick their favorite from the following mascots: a falcon, a lion, and a panther. The results are shown in the table at right. Find the experimental probability that a randomly chosen student prefers the lion as the mascot. All right, so they surveyed, they received all of these votes, and they want to know what's the probability of some students saying, yep, they voted for the lion. Okay, so we know that the probability that you're going to choose a student who voted on the lion is going to be the number of students who chose the lion out of the total number of students surveyed. So there's your basic probability. Of course, we need to simplify this. So 76 divided by 4. Come over here and grab my calculator really fast because here that off. 76 divided by 4 is 19. Nice and easy prime number. And 200 divided by 4 is 50. So 19/50ths is our fraction, and then a percent would be 38%, and then a decimal would be 0.38. So pick your version of how you want to answer that. I don't care again if it's a fraction or a percent. I'm going to pause it here, running out of that 15-minute time clock here. And when we start the next video, you'll have some exercises from these first 2 examples. So be ready for that.